Welcome guys, welcome to the second episode of Object-Oriented Programming in PeopleSoft tutorial. Let's continue where we left off. Just a quick recap. In my previous episode, we understood what is object-oriented programming. We also practiced programming using object-oriented approach. In this episode, we will quickly go through some popular programming languages and what kind of programming pattern they follow. The rest of the episode, I'll focus on what is encapsulation, why is it necessary. We will also do a simple practical exercise to implement encapsulation on a PeopleSoft application. Along the way, I'll show you how to implement security within object-oriented programming using access modifiers. Since now you know what's coming, without any delay, let's get started. Now let's go through some popular languages and see what kind of programming pattern they follow. Old languages like C and Pascal follow procedural oriented programming. Languages like Java, C++, and even PeopleCode support both procedural oriented programming as well as object oriented programming. They are not pure object oriented languages because not everything defined is an object. On the other hand, languages like Smalltalk, Ruby, Scala are pure object-oriented languages. Now let's discuss our topic of the day, encapsulation. When I think of encapsulation, for some reason, capsule comes to my mind. Generally, we take a capsule when a doctor prescribes it for some health issue. We don't care what's inside the capsule, but we take it to solve our health issue. Likewise, when we create our object, we must ensure data and logic related to our object is well encapsulated without exposing key details to the external world. Just like how we use capsules to solve our health issues without knowing underlying details, we should provide the flexibility for the other programs to use our object without knowing underlying implementation. In short, encapsulation is nothing but separating interface from the implementation. In other words, separating what it can do from how it does it. You might ask me, what is the main advantage of encapsulation? Answer is code maintainability. When we encapsulate our object, we can change or enhance our implementation whenever we want to without impacting external programs. Let me illustrate this with the help of the code that we wrote in our previous episode. Here is a simple PeopleSoft page that we worked in our previous episode. Basically, this page is used to calculate addition. If I input some number, provide the second number and click on add button, it would add these two numbers and display the output here. In order to accomplish this task, we have created a class called calculator and we have defined two properties, number 1 and number 2. Basically, we are exposing these two properties to the external world. The actual calculation happens through this method called calculate addition, and we invoked this specific class in our button field change event. We are basically populating the two properties number 1 and number 2 from the data on the page, and finally we are displaying the output value based on calculate addition method. Just think here for a second. If I go back to my class, imagine if we have to make changes to the implementation of our calculator class. It's very hard to do so because the reason being we already exposed two properties of our class to the external world. If I have to change number 1 to number 4, it won't end here. I have to go back to all the places where number 1 is referred from our class and make the same changes. Of course, making these changes is not fun and it's an expensive process. This is one of the classic examples where we haven't encapsulated our object properly. Let's fix this. In order to fix this, let's go back to our original calculator. I am not going to define these two properties. I will provide additional parameters for my method itself. I would say as number 2 as number, and here I would calculate number 1 plus number 2. And let me go ahead and save my logic, and I will go back here. Now let me pass the required values to our method. I will pass this in place of number 1, and I will pass this in place of number 2. And now I will delete 2 lines of code because they are no longer necessary. I'll go ahead and save our logic. Now let's try to use our calculator. It is working as expected. Now let's do one more practice exercise from the scratch, where I will show you different ways to secure object data, the concept of constructor, get set methods, as well as we will practice encapsulating data. Alright, let's get started. Let's take a look at this simple application. This page is basically used to calculate simple interest. Imagine this page is used by some bank. Since interest rates changes every day, let's assume they don't want to display on this page. Here, customer can enter the amount he planned to invest in the bank and how long he want to stay invested. And after clicking calculate, the system should calculate the total accrued amount that includes the interest and display it here. Let's implement this calculation functionality using object-oriented approach. I opened my app designer. Let's open the same application package that we created in our previous episode. I remember the name is demo. Let's open our app package. And this is the class we created in our previous episode. As we discussed in our first episode, the first step is we should model the solution through a class. Depending on the problem, there could be multiple classes needed because each class should have one single responsibility. In our case, I think one class should do it. Remember, there is no one way to model the solution or any cookbook method to do this. We will start in a very rudimentary way and improvise as we move along. I'll go ahead and create a class called Simple Interest Calculator that does the calculation for us. Let me go ahead and do that. I'll right click on app package and class. Let me name our class Simple Interest Calculator. I'll click OK and I will double click on my class. Let me go ahead and define our class. I can name it X, but when you save it, system will automatically replace the class name that we provided. I'll go ahead and save. As you can see, our class name is updated. Now let's take a look at the formula for Simple Interest Calculator. This is the formula for Simple Interest Calculator. Basically, there are 3 different variables. P means the principal amount, the amount invested by the investor, and R would be the rate of interest, and T would be the time period. This is the formula that we need to use to calculate simple interest. And let's go ahead and first define these 3 variables. Now I will go ahead and define our 3 variables as properties. Our first property of number type interest, let me copy and paste it here, and let me rename the interest to principal amount and years. Properties are nothing but external facing fields that any program outside of our class can access either to retrieve a value or inject a dynamic value into our class. Think of them as public variables that anyone can access. Now let me define the method that actually does the calculation for us. Method calculate accrued amount, and it returns a number. Now let's implement this method. In order to implement method, we need to specify method. Let's copy our method name, do end method. In interest of time, I have already typed the formula used to calculate simple interest, and this is the formula. The keyword, this means we are fetching the specific properties within our class. This is the principal amount. Likewise, we are fetching the interest and the number of years, and basically we return the total amount of interest that was calculated. I'll go ahead and define our total variable. Within an app class, every variable should be defined, else PeopleCode will throw compilation error. I'll go ahead and save our app class. So our app class is ready. Now it's the time to fire up this app class in our button field change event. Here I am at button field change event. Now we are going to pull an object from our class to perform our calculation. I have a funny example. You can think class as dosa batter and object as dosa. Just like how we cannot eat dosa batter directly, we cannot directly use properties and methods of our class in our program. We have to make dosa, which is creating an object. Since I have already explained you how to do this in my previous episode, in interest of time, let me paste the code here. Here we are importing our class into our PeopleCode event. Next we are declaring object just like any other variable. And this is how we are creating an object. Next we are populating all the properties related to our object. And finally we are calling the calculate accrued amount to perform the calculation for us. I will go ahead and save our code now. Now let's try our solution. I will invest $10,000 for 5 years, and we have hard-coded the interest rate in the back end. I'll go ahead and click calculate. As you can see, it has calculated simple interest for the invested amount. Even though our program was working, but this is not one of the best ways to write the code. The reason being, as you are seeing here, we are allowing an external program to manipulate the interest rate. It doesn't feel the right way, because tomorrow if bank changes the interest rate to 3.975, we have to modify the code in all the places our code was invoked. So let's not expose our interest rate. I'll go ahead and open our application class. We have a few ways to fix this problem. I can mark interest as read-only, so the external program can just read the bank interest rate. Or else I could use a property called get, which would allow external program to get the value of interest rate. With get, we have more control, as we have to define a method called get, as I am doing here, which can control what value should be returned to the external program. Now I will save our code. Let me navigate to our button field change event. I will remove this line of code since we are no longer allowing third-party programs to update the interest rate. Let me quickly navigate back to our application class to discuss one more property. The property name is set. It's just the opposite of get. Set would allow third-party programs to manipulate the class properties, but in a more controlled fashion. Just like get, we have to write an extra block of code for set method, which we can use to validate the data or do some processing instead of allowing third-party programs to directly update our class property. I hope you got some idea. Since it is not relevant in our case, I'm going to delete the set property. Since topic today is encapsulation, we have to ensure we expose just the relevant fields. I do not want to expose these two fields because in the future, if I want to change the model of my class, I have to modify all the places where these two fields are set by the external programs. Let's reduce some dependency. For time being, let me remove all the public properties. Let's allow external programs to pass values to our class through method signature. Let me go ahead and do that. Now let's focus on the interest rate. Let's explore a different way to pass interest rate. The way I am referring here is through constructor method. Constructor method is the first method that gets executed when we invoke an instance of class. Let me go ahead and write our constructor method. Constructor method is just like any other method, but it will have the same name as class and it will not return any value. So we can specify all default processing in this constructor method. Let's use this method to pass our interest rate. Remember, we plan to hide interest rate from the public view. We can do this by defining interest as a private variable. In order to define private section within our class, we have to use the keyword private. All variables and methods defined under private are specific to this particular instance of class. No one from outside of our class can access this variable. Let me delete this get. Now I will populate the value of interest within our constructor method. That's it guys, we have encapsulated the data and methods as best as we could. After we are done here, let's go back to our button field change event. We don't have these variables as public facing. Let's go ahead and delete that. Before deleting that, let's pass this value directly to our method. Remember, we changed the signature of our method. Let me delete these 2 lines of code and I will go ahead and save our program. Let's refresh our page. 10,000 invested for 5 years will yield me 11,938. That's it guys. Today we covered a lot of ground. We started with programming languages, then we covered encapsulation, get set methods, constructor method, and finally private variables. In the next episode, I'm going to cover the concept of inheritance. That's pretty much about it for today guys. If you like the content, don't forget to hit that like button below. And if you want more of these videos, subscribe my channel. Thank you so much for watching. See you next week. Until then, keep learning.